안녕하십니까.
Good morning, everyone. As introduced, I'm Shin Dong-Shik. It's a great pleasure to speak before you with all the distinguished guests. And I'd like to thank Professor Lee Yeon-seung for having me today. And it is a great honor for me to deliver a keynote speech to you. This is a very meaningful session, and the very fact that you have me here today shows that I'm still active in this field, and maybe you chose me because I'm the eldest person in this industry who is still working. When it comes to the shipbuilding technologies, well, I went to Seoul National University in the 1950s, so I'm the class of 50-something. At the time, that was when Korea had seen an outbreak of the Korean War. And I was full of passion, and I wanted to make contribution to the shipbuilding industry. So for more than 70 years at home and abroad, I was focused on the shipbuilding activities. And looking back, even though I reached the age of 90, when it comes to carbon capture, transport, and utilization, or CCUS, I'm willing to dedicate the rest of my life to CCUS. I believe that this is the most effective and practical technology that we can utilize. And CCUS is something the shipbuilding industry can make contribution to. And also, it's a big challenge and a task for the rest of the humanity. I fully understand that all of you in this room knows what CCUS means because you're experts. But anyway, when it comes to the CO2, which is leading global warming, well, it's about 40 billion tons a year. And in Korea, CO2 is emitted, and the volume is about 700 million tons. So you can tell that we are huge contributors to the generation of CO2 in order to keep limited to well below 2 degrees Celsius. We have to do something right away so that by 2050 we can achieve true net zero. And that is actually the recommendation of the UN IPCC, and that is the foundation that we are all working on. In order to achieve net zero, we can think of photovoltaic energy, renewable energy, and nuclear energy. And you understand that all these are brought up because they can produce zero carbon, but I don't think these present technologies will achieve full net zero. And especially in Korea, we are not very well equipped with facilities for renewable energy. And when it comes to construction industry, where we are heavily dependent on cement and other aggregates and resources, and as many countries are dependent on fossil fuels, achieving net zero using present technologies is not very feasible. This diagram shows how we're dependent on fossil fuels. So when it comes to CCUS, it is about using coal, gas, and at the same time we capture CO2 so that this can be utilized and this can be stored underground permanently. So fossil fuels, after they're used, And after they emit CO2, it's basically putting them back where they were. So indeed, it's about achieving true net zero for the ecosystem. And according to Net Zero by 2050 report, the CCUS technology is the most economic and feasible technology for countries around the world. The tables that you see right here was prepared by the IEA and Bloomberg, and it looks at 3 different scenarios. First, using renewable energy sources to control climate change to achieve net zero. For that, we need a huge investment to achieve the first scenario. So just a ballpark figure, but roughly it's an astronomical investment that we need with more than 1,600 trillion won. The second one is using coal and gas along with carbon capture technologies. And in that case, it's about 960 trillion dollars. And the third one is utilizing nuclear power. And how much investment it is needed? 1,380 trillion. So from these figures, you can tell that CCUS can be a feasible alternative. So the IEA, amongst many other technologies, CCUS is seen as the most preferred way or preferred technology. CCUS is not something simple. It's a very big-sized plant project. So regarding the first step, which is the carbon capture process, we're still working on this process. And I believe that this will provide us with an economical commercial model. For shipbuilding, we have this block process for standardization. And with standard blocks, we increased efficiency for shipbuilding, and that led to higher productivity. For carbon capture as well, we believe that the modular approach and standardized modular approach will provide us with greater opportunities. And most of the areas where carbon captures will be done are located in coastal areas. So if we develop standardized systems, I believe that this will become a very profitable area for the Korean economy, where we can be active and have a leading technology on the global stage as well. And this one is a combined cycle power plant developed by Seoul Shipbuilding and Marine Engineering. So compared to what we see, well, actually, we do have technologies and equipment and fabrication techniques to be able to produce such a power plant. And this combined cycle power plants, which are widely used around the world, can be developed further in Korea as well, so that we can play an even greater role in this industry on the globe as well. And carbon-fueled power plants, we have 7,000 of them. And these power plants should be able to capture or remove CO2, but we can't really remove CO2, right? Because we can't remove all the energy sources. So what that means is, for these 7,000 power plants, if we can secure 1%, at least 1% of the market share for the power plants. Well, we would need 70 or 700 of these combined cycle power plants. The highest value added LNG, we have more than 90% of the market share for LNGs. And given the technology, given the level of technology that we have, it's not very difficult for us to come up with such an idea like a floating combined cycle power plant. And I believe that we can play a leading role in this field as well. And in the next stage, which is storage, shipbuilding industry can also play an active role as well. Even though we produce lots of greenhouse gases, we do have facilities to store CO2. Like I said, Korea produces 700 million tons CO2. But actually, what we utilize, what we use at the end of the stage is only 100 million tons. Then what about the rest? The rest can go to foreign countries. In the Glasgow meeting of COP26, we made a commitment of reducing greenhouse gases by 300 million tons. It's 300 million tons. Out of these 300 millions, if we can export 100 million tons, then that will be a huge figure. So if you think about LNG, it's slightly bigger than 50 million tons. And in order to transport this 50 million tons, we're working with related companies, and there are huge profits involved. But I'm not talking about 50 million tons right now. It's 300 million. It's such a big number. So if we can use domestic technology, using local carbon capture technologies, and if we carry this to Southeast Asian countries, for instance, then the demand for vessels will be huge. And that will be a very profitable business for 3 major Korean shipbuilders. So that's why these major shipbuilders built this concept for dual carriers. And also, they are trying hard to obtain AIP, or approval in principle. So about net zero, and in achieving net zero, there are so many things that shipbuilding companies can do. And CO2 coming from industrial plants, it's not just the only source, but we also have CO2 from vessels, and actually the volume is huge. We have about 100 or 120,000 vessels around the world. And these vessels produce 1 billion or 1.2 billion tons of greenhouse gases annually. Of course, we can't get rid of all these, and of course, we have to turn to alternative fuels, including LNG, ammonia, and so on. But up until that time, we have to keep operating these vessels, and we would need a mandate to capture carbon. So we had a presentation, and we listened to the case of Panacea, how it is developing carbon capture technology and trying to commercialize this technology. So regarding capturing carbon from vessels, as you may well know, IMO developed indices and regulations, including EEDI, EEXI, and so on. So it's not just IMO, but also the EU. We're seeing stricter regulations going forward. In the future, in order to tackle future challenges, we have to think about this 3D. It's not just the theme of today's conference, but the first D, which is decarbonization, is a big, huge topic. Second D is about different technologies and different industries, diversification. And the third D is digitalization. It's about how we can digitalize, diversify, and decarbonize. In the shipbuilding industry, when it comes to decarbonization, digitalization, and diversification, we cannot wait further to take actions. For decarbonization, we are developing and working on eco-friendly alternative fuel for vessels, carbon-free fuels, and also advancing onboard carbon capture systems and green marine hydrogen and so on. In the field of digitalization, we are talking about autonomous vessels, marine robot mobility, and smart green ships. And this is led by CRISO. In order to increase efficiency, we need to dramatically improve resistance efficiency. And in order to improve efficiency in a drastic manner, we have lots of R&D projects around smart green ship projects. For diversification, we're talking about floating airports and floating cities, and we are seeing the development of scalable technologies for these new concepts. And for VLFS, very large floating structure, we have seen lots of progress in the field of studying this VLFS. And the city of Busan is considering Kadokdo as a floating airport. And I believe that this can be a very feasible and meaningful approach. So the efforts of the last 2 decades will bear fruit after all this hard work. In order to achieve all these objectives, this is the R&D vision that we need and we came up with, as you can see on the slide. And led by CRISO, these activities are seeing progress very actively. So this particular table is actually developed by CRISO, and I stole it. Well, my apologies to Chairman Kim Boo-gi for stealing the slide. But anyway, I talked about many things, many different aspects and technologies that we can use for CCUS. And that was led by many passionate people. And going through the transition, we believe that we will develop our shipbuilding industry to the next level where we can actually lead the world logistics and net zero activities. and by making a huge contribution to this field. Well, we used to be a fast follower, and we wanted to catch up with all the advanced nations around the world, but we were not happy with stopping to be a fast follower, and now we want to be a first mover. And by being a first mover, we want to make sure that Korea shipbuilding industry stands at the top of the shipbuilding technologies. So I'm talking about we don't want to be a fast follower anymore, and we want to be a first mover. So I'd like to thank all the passion and creativity of yours. And based on your passion and creativity, I believe that we are able to see this sustainable technology like CCUS. So as long as time allows, I'm willing to play my role to make contribution. I design ships, and I founded this company, Korea Marine Consultants, and I designed more than 2,000 vessels, and also I did the supervision of these ships as well. So when it comes to the future vessels, we will always have this issue of CO2. And that's why I took interest in the issue of carbon capture. And I was very much interested in the development of technologies for carbon capturing around the world. I almost in real time, I monitored all these technologies and technological development. I'm greatly interested in CCUS and leading technological developers, because in terms of economics and safety, there are these leading companies and leading academics who are leading this technology. And today I wanted to touch upon more practical and more specific issues, because at the same time, well, we are sitting in this room, but at the same time, around the world, there are more than 10 conferences dealing with the topic of CCUS around the world. Unless we tackle the issue of CO2, the globe will become extinct. But even though we talk about it a lot, we do not really hear about what actions we took. But what matters is the actions we take. Have you ever heard of a story where they actually successfully captured 1% of carbon at least? That's what we want to hear. So the company I'm involved in is the company Carbon CCS, based in Oslo, Norway. And this company has more than 100 patents when it comes to carbon capture. And it is well prepared for delivering related projects. And since 2001, I've been working with this particular company based on close partnership. So this is a quick introduction to this company, Carbon. It's not an amine-based technology, but it's about using hot potassium carbonates, high temperature, high pressure-based carbon capture, and highly pure CO2 can be captured. This is a highly efficient technology of carbon. This can be applied not just to CO2, but it can be used for SOx, NOx, maritime compounds, and other pollutants. And this can also be used for the oil and gas industry in the US and widely recognized by the BAT. And on the basis of this source technology, across the overall CCS stages, we are working hard on commercializing and implementing the CCUS technology. So if we focus on the core technologies, regarding the CO2 in a stable and economic manner, how can we capture it? And second, about the captured carbon, how can this be safely liquefied, stored, and operated? Third, the captured carbon can be transported through tank lorries and other vehicles. So the next one is about handling this captured carbon. And this is related to building economical carrier for CO2, building economical CO2 carrier. So if you think about the size of CO2 carrier developed by 3 major Korean shipbuilders, it's about 40 or 30,000 tons. But in this particular company, Carbon, it's a jumbo-sized CO2 carrier of 187,000 tons, and it applied for an AIP from DNV. So if the approval is given, then compared to 40,000 tons, it can be much more economical. And next, about capturing carbon and how this can be stored in a provisional manner in the vessel. That's about onboard carbon capture storage. And next one, about utilizing captured carbon and how this can be stored, how this can be injected. Many people might think that putting it underground or into the sea is not that difficult, but it actually is a very challenging task, and we need lots of safety measures to make sure that it is done safely. So this table is what I wrote, what I prepared. And in order to achieve net zero, it's not just about capturing carbon, but we also have to think about first we have to capture carbon from a host plant. For that, we needed technology. And after that, with the carbon captured, we have to liquefy carbon. And we need loading, unloading systems. We need CO2 carriers. So across the whole value chain, the technologies should be able to cover all the activities across the value chain so that this can be put into practice. So if one step faces a glitch, then we wouldn't be able to move on to the next stage. So working with the Norwegian company, I thought that I could be a technology provider, and also across the value chain, all these are independent processes. These processes should be optimized, integrated, and orchestrated. By achieving this, once we achieve the harmonization of these independent systems, then we can see the full, complete value chain, and that will require huge investment. And also regarding development technologies, in order to secure funds, For instance, it's not just between governments, but it can be also a back-to-back guarantee systems so that we can finance this technological development. So at my old age, well, it's not really about trying to earn more money, but what I want to achieve, what I want to see is to become the best world-class CCUS player. And I want to see Korea becomes the best player in the field of CCUS. Up until now, CO2 was seen as waste, but now we can see it as a resource. In the US, it started to see it as an asset, not a liability. And the US is turning this liability into an asset. And the project that requires the biggest volume of CO2 is EOR. So from a depleted oil field, well, literally it's depleted, but still 20 or 25% of the field is still there in a solid form. And if we put CO2 into this, then it becomes softer and we can pump it out. So this is the example of North Dakota. By putting 1 ton CO2, this shows how much more we can take out of this field. So the incremental recovery was 155 million barrels with EOR. So the price for CO2 is between $80 to $100. Let's say it's $100 for the convenience sake. And given this incremental recovery, well, it's about $500, which can be more profitable with this technology. So even though the demand for CO2 is a fixed figure, we need much more CO2, which is 156 billion metric tons. So by utilizing CO2, we can create wealth. That's what this table, what the slides are talking about. So once again, I walked you through the technology that we developed and how amazing this can be. Then you might be wondering what would be the commercialization status. So this is the 150,000 ton grade vessel. And this is the Oxy Group. And this is the contract that we're pursuing. And this is a 6,000 megawatt plant. And we can capture 48 million CO2 a year, and it required 5 billion, which is a huge investment. So that is the level of funding that we secured in the US, and this facility will be complete by 2024. So on the basis of this project, we can use this as a benchmark and have expanded projects in Korea as well. So I might be running behind my time, but I'm trying to say that we do not have much more golden time left. It's time for action. So instead of just having discussions around the tables, instead of just having armchair theories, having pros and cons, now is the time to deliver. In December, we will have the CCS conference, CCUS conference in London, and this is the theme of the conference in December, time to deliver. We have to stop having discussions, having lectures, but it's time to deliver. So under the circumstances, I believe that it is indeed meaningful that we are here together with all the experts, and this is a meaningful effort. And it was a great pleasure for me to speak before you as well. I hope you can be warriors for the climate change. And that was my keynote speech, and my apologies for running behind my time. Thank you very much.